Some properties of liquids. There are many properties of liquids, but we're going to look at 5 major ones. I'll introduce them by these virtual experiments. We'll start by getting a beaker and filling it with water. Here it is at 40 milliliters. Now we'll get a different container with a different size and shape. It's a graduated cylinder, and we'll pour the water from the beaker into the cylinder. Notice the volume is still 40 milliliters. Now let's take a pan and pour the same water from the graduated cylinder into the pan. The pan contains 40 milliliters as well. The water is just spread out now over a larger area. We can take the same water from the pan and go to the sidewalk and pour it over the sidewalk. The shape will look a lot different, and thickness of the water will be much smaller, but the total volume of the water is still 40 milliliters. Of course, we'll lose some water from evaporation over time, but that doesn't change the fact that at the beginning, the volume of water in each of these containers has remained the same, 40 milliliters. From this example, we can already see 3 properties of liquids, in no particular order. The first one is that liquids have no particular shape, so we say they have indefinite shape, which means they take the same shape as the container they're in. The second point is that they have a definite volume. The third one is that clearly liquids are fluid, which means they can flow or be poured. I should point out that although I used water as the example, here is Niagara Falls, Canada, these properties are true of all liquids. Some are oil, vegetable oil, kerosene, and alcohol. These are probably the most common ones you would encounter. Let's bring in the beaker of water again, and this time introduce a piston, which can press down on the water. We say that it exerts pressure on the liquid. As we see, the liquid is not being compressed. It actually does compress a very small amount, but the amount is so small we can't see it with our eyes. This leads to our 4th property of liquids. They are incompressible. Now it is interesting that this incompressibility of liquids has certain important applications in our lives. For example, let's look at the hydraulic braking systems of cars. When the foot presses on the brake pedal, pressure is being applied on the fluid. The fluid doesn't compress, but the force is transmitted throughout the liquid. For example, the red arrows show the force being transmitted to the front brakes. The liquid pushes against the blue pistons, which eventually lead to friction on the wheels to slow the car down. Similarly, the blue arrows show the force being transmitted to the rear wheels. What would happen if the fluid were compressible? Well, as you pushed your foot on the brake pedal, your foot would go right down to the floor, and there would be no braking action. In a similar way, the use of a syringe relies on the incompressibility of liquids. Here we see a vaccine being administered through a syringe. Notice how the black rubber seal at the end of the plunger is able to push the liquid out through the needle. Again, this is possible only because the liquid is incompressible. Now, let's take our beaker of water again and heat it with a Bunsen burner. We're not going to heat it a lot, certainly not to boiling. With heat, the liquid will expand very slightly, but not enough so that we can see it in this beaker. So the 5th property is that liquids expand only slightly with heat. But there is one situation where adding a little heat will cause enough expansion for us to see. Can you think what it is? The answer is in thermometers. Look closely at this temperature thermometer, and you'll notice that the tube has a very small diameter. We say it has a small bore. The addition of a small amount of heat will cause the liquid to expand slightly, but since the bore is so small, the slightest expansion will be visible. In this clinical thermometer used to measure body temperature, the liquid is mercury, but the same principle applies, and the expansion of mercury is readily detectable in this thermometer. Of course, nowadays, thermometers like this are being replaced by digital thermometers, which operate on a completely different principle. So these are 5 of the many properties of liquids, probably the 5 that are most important for you to know at this point. This ends the video on some properties of liquids.